What's going on, people? Mr. Phillips here. Thank you for calling Verizon. How do you like my new headset? Isn't this cool? I got this rad microphone stick. Virtual baseline heat flow lab sheet. Virtual baseline heat flow lab sheet demo. Graphing, you're not going to have to graph on the follow-up, but you're going to need to know like what your graph should look like or how to set up a proper graph. You'll see. So here are my two data sets plotted on the same graph. It doesn't look too good. First of all, look how flat and sad those lines look. If we set new y-axis mins and maxes, would it effectively zoom in on the graph and make it more dramatic, make those flat curves steeper? Yes, of course they would. So let's do that. What would be a good new min, y-axis min for this plot? 70? There we go. That's better. All right, what would be a good new max? 80? Cool. Oh, look at our title. Our title is currently a question mark. What would be a good title for this graph? What would be a good title for it, given that our two variables being plotted are temperature on the y and time on the x? You have two good possibilities, options for a graph title here, given those two variables. I'm going to go with, I'm always a fan of y versus x. So in that case, what's our y variable? Yes, temperature. Versus, and our x variable then is time. So temperature versus time would be appropriate. Also, another possibility is the effect of, whenever you're doing the effect of, it's the kind of the opposite. It's the effect of x on y. So in this case, the effect of, what's our x variable here? It's time. The effect of time on temperature. And that has to make sense in your brain too, in your noodle. Because does time affect temperature? Does temperature affect time? If temperature affected time, we would be living in one cool reality. If like the temperature on the thermostat or on the thermometer, as it rose, like time went faster, and as the temperature went down, time went backwards or slower. Yeah, that definitely doesn't happen. But that would be pretty neat. So, do we need minor grid lines? Or do you think we could grab somebody off the street? Because people are always grabbing people off the streets. So do I have a loose clippy? Yeah, this thing is flying around. You can't really see it, but it's a little clippy cover. Whatever. Maybe I kind of like it. Grab somebody off the street and say, hey, look, where's this data point on the x-axis? And they'd be like, oh, I don't know. It's somewhere between 0 and 5. They wouldn't know because there are no minor grid lines on the x-axis, and there's this giant space between 0 and 5. You need to make your graph as precise as possible so you could really pinpoint those data points on your graph. Grid lines and ticks. You ever been bitten by a tick? I have multiple times. I'm a big huge fan of those ticks, Doink! And then switch this over to horizontal axis. If your majors are counting in 5, 0, 5, 10, 15, well, then make your minor count 4. So it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it for the graph. Looks good, doesn't it? So anyway, about ticks. Yeah, I'm a big fan. Whenever you go to gently pull them out, people, the best way to remove a tick is grab some tweezers. We always take tweezers with us when we camp and hike and stuff. Tweezers, grab as close as you can to the mouth bits parts where it goes into your skin, and gently squeeze. Get a good grip on it, but don't squeeze too hard. You don't want to squish the thing, and then you get the head part like trapped in your skin. So you grab it gently and slowly pull, and it'll pop out. Okay, don't pull too hard. Make sure you get close to the skin, because otherwise you'll pull off its body and leave its head behind in your skin. Okay, and whenever you remove it, keep it in a baggie. All right, keep it in a baggie with little teeny holes poked in it so it can stay alive. Because if you start developing you're not sure if you got Lyme disease or not, you have the tick, and you can take it to get the tick to get tested or something, so that see if it has Lyme's disease. Anyway, delta T's. First of all, what are the equations for calculating your delta T's? I already gave you the delta TH equation in terms of the variables. THF minus THI. Do you know what each of those stands for? Temperature, heating, final. THI is temperature, heating, initial. Heating lasts from 0 minutes to how many minutes? When does heating stop? Yes, 10 minutes. Heating goes from 0 to 10. The temperature at 0, okay, what would that be? That's THI, temperature, heating, initial, or initial heating temperature. The temperatures at 10 minutes, what temperature would that be in terms of variables? THF, final heating temperature. Okay, so heating occurs from 0 to 10 minutes. All right, delta TC, cooling temperature changes. What are the variables for that? Well, it's still going to be final minus initial, but instead of THF, temperature heating final, it's going to be temperature cooling final, TCF, minus temperature cooling initial, TCI. All right, and the same thing over here. Slurp. All right. So yeah, cooling goes from 10 minutes is when it starts, because right at 10 minutes, it goes from heating into cooling. So right at the 10-minute mark is when the temperature is recorded and the lamp is unplugged or turned off at the same time. So it seamlessly transitions from heating into cooling. So at 10 minutes, that is both the final heating and the initial cooling. All right. So I should probably switch this like blue for cool. Just so cool. So cool. All right, TCI, temperature cooling initial at 10 minutes. And then you cool down. So cool, feel the chill. TCI, you cool down for 10 minutes. From 10 minutes to 20 is cooling. So at 20 minutes, that's your final cooling temperature, TCF. And net. People are wondering, like, people miss the boat on net. They're like, wait, Mr. Phillips, what's a net? Is that, what, do we get nets? Net is another word for overall. If your house starts at 70, goes up to 100, and then drops back down to 70, overall, there is no change because you started at 70 and ended at 70. It doesn't matter if you could start at 70, go to 1,000,000 degrees, and then go back down to 70. The net temperature change is 0. To find net, you take your very last temperature minus your very first temperature. The very last temperature is your final cooling, TCF, right? That's the very last temperature. And the very first temperature was, in terms of variables, THI, the initial heating temperature. So net is actually TCF minus THI, your very last temperature minus your very first. I got a green. I did it. I did it. Is my thing still on? Uh-oh. 78 THF minus 72 is your THI. All right, 78 minus 72. I got a green. 78 minus 72 is 6. Wow, I got it. I'm good. You know what? I'm going to break this up into 2 parts because I'm afraid my microphone isn't working anymore and I don't want to waste any more time.